Wi-Fi or something else. So let's start that topic. Okay, so somebody is joined again. Who is this? Karishma. Hello, Karishma. How are you? Are you there, dear? So Karishma, like your voice, your mic is not working properly. It was a very like heavy voice is coming from your end. Like it's not your voice. I think maybe due to that's because of mic. Okay, so electric charge. Let's start with the topic without any delay. That's the electric charge. The electricity is totally based on the electric charge. Like everything is based on electric charge. The flow of electric charge is nothing but the electricity. How many of you know that?
Yes, sir.
Raise your hand. Yes, okay. Okay, everybody, I have enabled the focus mode, so all of you can switch on your videos. So I will be only seeing your videos. Nobody can watch your videos, or you cannot watch the videos of others as well. Only the teacher can see the videos. Okay. Okay, so electric charge. Let's come to the topic, electric charge. So basically, how many types of charges are there? Can anybody tell me?
Positive and negative charge.
Positive and negative. So two types of charges are there, positive okay, yes, Karishma. And positive and negative. So positive and negative charges are there. The sign is positive, dislike, and the sign is negative, dislike. Okay. Clear? Can anybody tell me what is the net charge on a material, on a substance? Net charge. Is there any net charge on a body? Everybody. Tell me.
6 raised to 10, that one.
I'm asking net charge. Like suppose that I'm having this pen. Is there any charge in this pen, on this pen? No, no. There isn't any charge here. Everything which yes, it will be zero. The net charge on a body is zero. Right now we are talking about we are not saying that the charge is electric positively, the body is positively charged or the body is negatively charged. We're just saying that the net charge on the body. So if you say that, it's assumed to be that the net charge on the body is zero. When we specifically add the word positively or negatively charged, then we can say that it depends. Clear?
Yes, sir.
So, okay. So when we have two bodies, suppose that one body is there. So number of positive charges are equal to number of negative charges. Yes or no, everybody? If the body has the net charge 0.
Yes, sir.
Just a moment. Just a moment. Just give me a moment. So, so negative will be, so that's why the net is 0. See na, every like positive and negative do what? They complement and neutralize each other. Positive subtracts the negative 1 if there are positive 4 and there is negative 4. So you will get the answer 0. Everybody, at
Yes,
least
sir.
respond. Got it? That's
sir.
how.
Yes,
So whenever the body is basically, when we take this example, we say that right now the body is in neutral state, natural state. There is no positively or negatively charged particles on the body. Clear? So what happens is that, suppose that you have got a very good news, and what you do is that like you get very excited. Clear? How many days you will be excited and you will be like very happy for that if you have a very good news?
1 day.
1 day.
1 or 2 days.
1 or 2 days. If it's a very good news, like you have topped the board exams, that will remain for at least a month. At least a month.
Yes, sir.
Like it would, like when you will join the school and everybody will clap for you and you will be a star for the school. So that will be like around 1 to 2 months at least. Unless you appear in the 11th class exam, mid-term exams, because the 11th midterm exams are very tough. Okay, then you will just forget the happiness of the boards. Clear? So I'm not okay. So that will be at least 2 months. If the good news is very good, so it can at least stay at least 2 months. I'm just saying that. Yeah. So the body, so you will come back to the natural state again.
Yes, sir.
Very happy.
Yes, sir.
So same goes thing with the materials as well. They cannot be in excited state. They cannot be completely positive or completely negative charge for a very long time. They have to become neutral. They have to be, the net charge should be equal so that they can stable, because positive. So okay, do one thing is that, suppose that you are very happy that you have got the news that you are that you have topped the board. What you will do is that you will just jump and high and all the things. Suppose that suddenly while jumping, your basically you got an injury on your leg. Maybe sometimes happen, basically the twisted leg problem. Everybody, when we jump, we have the problem. Okay, so
Yes,
so you have to be in natural state. If you don't want any injury, if you want to be stable, if you are not in a stable condition, you will just be like you will be unstable, and that unstable condition is very prone to accident. Clear, na?
Yes, sir.
Yes, sir.
Suppose, okay, so that's why the body is, that's why everything wants to be in stable state. So if the body gets in excited state, excited means that there will be some positive, either positive charge on the body, or it can be negative. It depends that the body loses or accepts the electrons. How many of you know the concept valency and valence electrons?
Ma'am, me.
Okay, very good, Abdullah. And what about all? Hiba, Samina, Shweta,
Yes,
and
sir.
Kiran, and Adil?
Yes, sir.
Karishma as well? Yeah, okay, Karishma, okay. Very good. So valency is nothing but it's the number of electrons that the sub element will lose or gain. Yes or no? If it lose, the valency will be positive. If it's accept, the valency will be negative. Yes or no?
Yes, sir.
Because if suppose that Hiba, like I'm giving some money to Hiba, so I will be in positive because Hiba, I'm giving credit to Hiba. Hiba is borrowing from me, so he will be in debt. That means DEBT. That means curse. Have you got this?
Yes, sir.
Yeah. So that's why Hiba will be in negative, because she has to pay to me again. Clear?
Yes, sir.
So yeah. So that what's depend, the valency will be positive or negative, because it's very important right here to understand these concepts, because without this you cannot be like, you cannot understand the furthermore concepts. And okay, so one more example we have is that I will write down all the things, because understanding is a little bit, you have seen that I take the examples first, then write down the definition after this. Okay, suppose that it is a silk cloth. This is a glass rod. Clear? So, okay, so when you rub this silk cloth onto the glass rod, what will happen is that glass rod will lose some electron. It has a tendency to lose electron. Glass rod has a tendency to lose electrons. So what will happen? A positive layer will be formed. Here. And where will it's saying that positive layer is formed, which means that it has lost some electron.
Yes, sir.
Yeah, it has lost some electron, means that the electrons will move to the silk cloth. The moved electron will be equal to nothing but the positive charge, because if we add these charges, basically the net charge will be 0. Suppose that. Clear? Yes or no? Everybody, yes or no?
Yes, sir.
Yes, sir.
Yes, very good. So you can see that when this glass rod, it has a tendency to lose electron, it has a tendency to accept electrons, and the net charge will be 0. If we add these charges, the net charge will be 0. It means that charges are not created, neither be destroyed. Charges can neither be created nor be destroyed. That there will be only a transfer of charge between all the materials. Like for some time, this glass rod has lost some electron, but after 2 milliseconds, the excited state is very, very low for the particles. So they will come back to the glass rod. Okay, and it will attain the neutral state. This silk cloth has also attained the neutral state. Clear?
Yes, sir.
Very good. So let's understand the properties of charges here. Like charges repel and opposite charges attract each other. This is the first and most common property. Suppose that like charges means, suppose that two charges are placed here. So this is a positive. Okay. Three charges are placed here. Okay. So one is, I will explain why they attract and why they repel. This is positive and positive, and this is negative charge. Clear? So what happens is that when the charges, whenever we take the word charges, so there is a region in which the force of this charge will be experienced. So how many of you experience, like, have you seen the very high tower, like in which the high voltage is passed between cities? You have seen that in the open areas. The high towers are placed in which, like, they are connected, the wires are connected, and they are transferring the electricity to
Yes, sir.
different cities. So there is basically a restriction is placed around these high values. It means that there is a field around that tower. Yes or no, everybody? Electric field is produced because of the flow of charge. Clear?
Yes, sir.
So basically, a region will be produced by, like, with every charge. That's called as electric field. And these lines are called as electric field lines. Electric field lines are nothing but they will tell you in which direction the electric field, electric field is produced. Clear, everybody? Like, it's not like I'm just explaining this thing because you will be like seeing that why. Clear? So this is the, you can say, the positive charge electric field lines. Whenever we say positive charge, electric field lines will go away from the charge. Clear, everybody?
Yes, sir.
Yes, sir.
This concept is not there in the book, in the 10th class book. Only the visualization I'm giving you because it's an 11th, 12th class topic, like not topic, you can say the concept. But I'm only giving you the visualization, how to visualize why the opposite charge, the like charges repel and opposite attracts. See, electric field lines mean that this is a region of this charge. Yes or no, everybody? Suppose that this is a region of this charge. Clear? So basically what will happen, if another charge, suppose that if you place one another charge beside this, what will happen? See that electric field line is pushing, is basically applying some force on this direction, in this direction. And and this positive charge is applying in this direction, some force in this direction. What will happen? Will they attract or will they repel? They will repel, na? Suppose that you are one force is in this direction and one force is in this direction. Both are in opposite. Yes or no? So basically, they are applying to basically just like they are applying. They are basically trying so that they cannot merge. Have you seen the magnets, North Pole and South Pole?
Yes, sir.
So basically, South Pole and South Pole doesn't get contact, doesn't make any contact because they are opposite, like poles. South and South, but suddenly you take when the North and South, they will get stick. So the forces of these electric fields are in opposite direction. So you can see that directly. They are not getting, like, they are not going to attract each other. But when we talk about the negative electric field line, negative charge, the electric field lines are towards the charge. towards the charge. See, just you can directly visualize this thing. I think you must have got the idea, like how they attract each other. The line I've produced. How many of you got the idea? Apart from Samina and Kiran, Adil got the idea. Eba got the idea. Very good. See, this electric field, okay, Shweta, very good, everybody. This electric field, positive electric field line is applying some force in this direction, yes or no? The electric field line is going away from this charge, but for this negative charge, it's towards the charge, yes or no?
Yes, sir.
Got it? This is saying away, like go away from me, but it's saying why? Because you're basically the force you're applying is in my direction, so I will attract to you. I'll get stick. Clear?
Yes, sir.
Any doubt?
No, sir.
Got it? So that's why they positive or the opposite attracts and the like charges repel. How many of you got the idea properly? Like I don't like it's just a visualization. That's why I've taken this. Adil, what about everybody? Shweta and Karishma. What about Samina? Samina and Kiran. Have you got this? That's you
Yes,
can
sir.
got it. Very good. Adil, Karishma. Okay, that's great. That's great. And like it's very good that you have got the idea. So next part. Next thing is electric charge is conserved. It can be a 3-marker question for you, everybody. For the exam, write the properties of electric charges. Electric charge is conserved. Conserved means charge can neither be created nor be destroyed. Have you seen the same line, the same statement for the mass as well? Clear? Only the transfer of charge will be there. You have seen this example. That's why before taking the properties, I've given you the idea of what basically happens when there is a positive and negative charges we assign to the materials. Transfer of charges takes place. So that's what the electric charge is conserved. Means that it can neither be created nor be destroyed. Clear? Next thing is
Yes, sir.
electric charge are added or subtracted algebraically. Are added subtracted algebraically means nothing but like the basically plus my addition and subtraction do we perform in the with the numbers. The same way we have to add and subtract the charges. Clear, everybody? Fourth is electric charge is quantized. Clear? Electric charge is quantized means that the charges are in discrete packets. It means that they have some certain numbers. You have seen that charges are number of electric. Okay, I will explain that thing for you. The formula is with the example. Q is equals to Ne. Q is the charge, total charge, N is the number of electrons, and E is the value of charge of electron. Clear, everybody?
Yes, sir.
I will explain that thing to you. Let me, okay. So basically, this number of electrons means that these are in integers. N is equals to 1, 2, and 3, and so on. So basically, this number is an integral multiple, integral. So if the number is integral, so the value of charge will be in integral. Everybody, at least yes, say.
Yes, sir.
Okay, very good. So let's take one example on this question. Then then you will get idea why I'm saying this continuously. Okay, so the question is asking how many electrons, number of electrons are there in the 1 coulomb of charge. Okay, so let's do this question. So solution is there. What the value of charge is given as 1 coulomb. One more thing is that SI unit of charge is coulomb. Positive C, not positive, capital C. 1 coulomb is given. 1 coulomb, na? 1 coulomb. What is the value of electron? The charge on electron is 1.6 into 10 to the power minus 19 coulomb. Clear, everybody?
Yes, sir.
So
Yeah,
Q
yes,
is
sir.
equals to NE. The formula is, so what we need to find the value of the number of electrons. So it is Q by E. Yes or no? So 1 by
Yes, sir.
1.6 into 10 to the power minus 19. Okay. If I take this in the numerator, it will become positive or it will remain negative. Everybody at least answer. Samina and Kiran, all of you, like everybody is open. Why? Like everybody is open to answer. Like I'm not for like see, 8 students are there in the class. I think 8 or 7. Yes, 7 students are there. So everybody is open to speak. Like I'm not specific because you know that speaking the name of 7 students is a lengthy task for me. Okay. So
Yes.
everybody is open to
Positive.
answer. Yes, it will become in positive, na law of exponent. When we take the basically a denominator and the numerator, there's a multiplication there. So what will happen? Negative will become positive and positive will become
It will become
negative.
positive.
1 by 1.6 into 10 to the power 19. So 10 by 16, I've removed this decimal into 10 to the power 19. So if you basically divide this thing, the answer will be comes out to be 0.625 into 10 to the power 19. If I take, can I take 110 from here to multiply with this number? Yes or no?
Yes, sir.
Very good. So it will be 6.25 into 10 to the power 19 or 18? 18. So it is the number of electrons. See, you can also take the 2 tens to multiply this to 625. See that 625 is an integral value or a decimal value. See that this whole number is an integral value. Everybody, yes or no? So have you got it? Why electric charge is quantized? Why there are certain discrete packets of electric charges? So that's why the word is used quantized. The number are fixed. Like that's the integral value. Clear?
Yes, sir.
Yes, sir.
Okay. Let me write down the value of charge is electron. Charge. Everybody write these things on your notebook. Okay, don't sit and watch. Charge on electron is minus 1.6 into 10 to the power minus 19 coulomb.
So, I missed little bit of talk.
What happened, Abdullah?
I missed little bit of talk, so I will.
Okay, I will give you time enough. Yes.
Yeah.
Proton. Positive charge is called as proton. The charge will remain the same for both because it's positive and negative. Only the sign is different, but the magnitude is same. Mass of electron (9.1 into 10 to the power minus 31). You have to remember these things because like it can be a case that the values are not given in the question paper of CBSE. So what you will do if this numerical comes out to be like from this topic? So remember these things. Okay, everybody.
Yes, sir.
1.67 into 10 to the power minus 27 kg. Clear, everybody?
Yes, sir.
Very good. Yes, Abdullah?
No, I said yes.
Okay. Just a second. Okay, so is that clear to everybody? Yes or no? Now, the next thing is that we need to identify which materials are which materials are useful to conduct electricity. Like, can you conduct electricity in any of the material? Everybody. Like, is it possible to flow the
No, sir.
electrons in any
No,
of the
sir.
material? There are certain materials which we use basically.
Conductors.
Yes, conductors. So we are taking the topic here, conductors and insulators. Okay, so the first thing is conductor. The material or substance which allows the electrons to flow and conducts electricity. It's called conductor, insulator.
Conductor.
Conductor. Very good.
Conductor.
Very good. So examples of conductors. Can anybody tell me? Like we have
Sir,
Copper.
metals.
copper. Okay. So
Iron,
you can say that
copper,
generally all metals conduct electricity. Like we have like so many metals, so
the
we cannot.
non-metals also conduct electricity, like graphite.
Only graphite is the answer, dear. Only
Yeah.
graphite is the substance.
वही मतलब वही sir.
हाँ,
वही बोल रहा हूँ.
हाँ.
खाली graphite.
Graphite metals, and the example is graphite. So Abdullah, you are very confident about the graphite. So can you tell me what type of structure does the graphite have?
Structure, like do you want me to draw the structure?
No. Just tell me. Is it what basically that every allotrope of carbon has a different structure? The type of basically the arrangement of atoms. Can you tell me what type of structure?
Sir, it is a 3-layered structure.
Very good. It's a three. And what kind of layer is this? Basically, what is the shape of the one layer?
Sir, I guess you can like not exactly oval, but like what do you say? It's like round in the shape of like what do you say?
Okay.
I can't give that type of example, or else it would be sound
By saying
funny. But,
something.
like, kind of oval, sir. Yeah.
Yes, Hiba.
Sir,
Shweta said. No, dear, not ball shape. Ball shape is for Buckminster Fullerens.
No, that is like very different.
Ball shape
like,
you are asking.
In a line, like round lines, sir. Round line.
Got it, Abdullah. Got it. Got it, dear. Got it. Don't
Sir,
like get panicked.
Chemistry में अच्छा होता है, physics.
Very good. Like if you are in good in chemistry, that's a good thing as well. At least you are good
Chemistry
in
and bio.
very good. Does not like which does not allow it. Abdullah बातों में लगा लिया. Which doesn't allow the electron to flow and does not conduct electricity.
Does not
conduct electricity.
Example is non-metal.
So plastic, rubber,
polythene, and everything
and
like
all the other non-metals.
Non-metal, plastic,
Rubber. Yes.
Clear?
Etc.
Like only it's enough. Got it, everybody? Yes or
So
no?
can
Please
you just
let me.
put one line above.
Yes, sir.
Each line above. Just once.
Okay.
Yeah. Thank you.
Okay. So basically, yes. So basically, the present free electrons, because metals have the free electrons. The metals are the thing which basically gives the electron, lose the electron. Yes or no? So in the material which has the free electrons are basically the conductor of electricity. Clear, everybody? Because now tell me,
Yes,
if you
sir.
want to send a message, what you need? You need a WhatsApp. Everybody got it? Yes or no? You
Yes,
need a
sir.
medium. You need a medium to send the message, na?
Yes,
Right?
sir.
Insta.
WhatsApp,
Yes, sir.
text, Telegram, Signal, like there are numerous. Instagram, Facebook, all that social media are used. So if you need to flow the electricity, you need the free electrons in the conductor. Sorry. You need the free electrons in a conductor to conduct the electricity, because flow of electrons defines the electricity. Nothing but flow of electrons is the electricity. Clear, everybody?
Yes, sir. Yes, sir.
Very good.
Yes, sir.
Yeah. Okay. So we have two types of electricity. One is static. Static electricity means that I've given the example of the what I was saying, the silk and glass rod is the example of static electricity. We have generated that electricity and the electricity is not flowing.
So that kind of like even happens when we like sleeping like with the blanket also, right?
Yes.
Woolen blankets and all.
Yes. And now next thing which basically this type of electricity which we'll be studying is that the dynamic electricity. Dynamic means the thing is in motion, which means that the electron in motion, that's why the electricity is generated. Clear, everybody? So next topic is electric potential difference. Clear, everybody? So that's the next topic of this chapter. Is that clear? Like any doubt in the previous topic what we have done so far?
No, sir.
Very good. Okay, so suppose that one charge is already present. Okay, let me explain the electric potential term to you so that you can understand in a better manner. Okay, so suppose that a positive charge is placed here. So basically, positive charge is placed here and the one charge is at infinity. Suppose that one, just let me take this part is it exactly. This is infinity for me right here. Clear, everybody? Because I don't have any. Sorry, I need to share my screen again. My screen got freezed. That's a very irritating thing for me. I don't know what like is it this is the problem of OneNote or my laptop. Clear, everybody? So let me draw this thing here, positive. So basically, if the positive charge is placed here, so it will have some electric field, yes or no? Everybody?
Yes, sir.
It will be having some electric field. There is an area around it which like the force can be experienced of this electric charge. Clear? So now, if I want to displace this charge from infinity to this point at a given point, suppose that it is point A. From infinity to point A, I need to do some work. If you want to take like if you want to get some chips from the market, you need to do work. You have to go downstairs, go to the market, come upstairs, and then you will eat in the bowl or even in the packet itself. Everybody, yes or no?
Yes, sir.
Yes, sir.
Yeah. You will do some work now for that.
Yes.
Yeah. So you will do some work. So basically the amount of work done required to move a charge from infinity to a point to basically I need to overcome this force because there is a force here. Electric field lines are there, na? They will apply some force. Basically, it will not allow to easily enter in the electric field. It will repel because this is a positive. It will repel. Like charges repel.
Yes, sir.
Yeah. So basically, the work which need to be carried out, which need to be required to overcome the force of this unit positive charge is called electric potential. Is everybody clear to me? Yes or no?
Yes, sir.
Any doubt?
Yes, sir. No, sir.
If you are taking a unit positive charge from infinity to a point in the electric field line of in the electric field region of a point, basically that's called electric potential. Clear?
Yes, sir.
Yes, very good. Let me write down the definition. So you can say that electric potential is nothing but electric potential can be a point in an electric field That's why I explained the like charges why repel each other with the concept of electric field lines. That's why I didn't draw here. Is that clear to everybody?
Yes, sir.
Yes, sir.
Very good. Okay, just a second. Let me have just written. Oh, electric field line is defined as whenever we use the word charge, it will have some electric field. Clear, everybody?
Yes, sir.
Work done. Moving a unit positive charge. Positive charge, unit positive, the value is unit because we need to basically define the electric potential. So we always take unit things in the definition. Clear? Positive charge from infinity to that point. Everybody clear? Eh? Everybody clear?
Yes, sir.
Very good. Shweta, Abdullah, Samina, Kiran. Like all 7
Yes.
students are there, so like it's not possible for me to recall all the 7 names, but I will try. Don't worry. Okay, so that's great. So electric potential is a scalar quantity. Like the path, is there any mention of the path by which path we are taking that charge? Everybody, at least tell me yes or no.
Yes, sir.
I'm saying that is there any mention of the path by which we have taken the unit positive charge from infinity to this point? No, no.
No, sir.
So there is not any
No,
mention.
sir.
So if the quantity does not have any direction, it means that's a scalar quantity. Clear, everybody?
Yes,
Yes,
sir.
sir.
Yes, sir.
SI unit of electric potential is volt. In the
Volts.
it's
V
divided V, capital V. Is that clear to everybody?
it is measured by voltmeter.
Abdullah, that thing is not electric potential is not measured by voltmeter. Electric potential difference is measured by voltmeter. Yeah.
Okay.
Okay.
No, I'm saying about like a volt. Volt is measured by voltmeter.
Yes.
right?
Okay. Yes, volt. Because the thing which is coming in front of you after this just the potential difference. So potential difference is the difference of potential difference of 2 points. 2 points. So basically the things which we use in the daily life is the potential difference. Clear, everybody?
Yes.
Yeah. So
Yes.
next thing is the potential difference. So let's come to the point. We have one. Suppose that I have 2 water tanks. Everybody knows that. Let's go in the. So basically, these water tanks have one water tank has the value of the capacity of water till here, and this is just like about to empty. Okay, and they are connected by a rod, or you can say pipe. It's okay. So now tell me, and the wall and this pipe is open. So will there be any flow of water?
Yes, sir.
Yes, sir.
Yes, very good. Which direction from which this is A
From
and
the
this
left,
is B?
from A to B,
A to B. Why?
because A has more water in it.
Because the value of basically this is at higher value level. Basically,
Yes, sir.
suppose that you are at the mountain and you throw a ball without any force. The ball will reach to the ground without any force itself. Clear? Because the ball is at higher level and basically it has to go towards the lower stability. Yes or no? Basically,
Yes,
when
sir.
you when you track the mountain, are you stable in that condition? Because you just feel that I'm just going to fail. I'm just going to fall. Sorry, because that's not a very
Yes.
stable condition for us. Well, I've experienced twice in my life that thing when I went to for the trekking. Clear?
Yes, sir.
Yeah. So
The
basically,
Mount Everest. Mount Everest.
Not Mount Everest. Have Gulmarg in Kashmir. Gulmarg and Sonmarg.
Okay. No,
Yeah.
sir, you go to Mount Everest from very
No,
easy.
dear. No. I'm fine. Like I'm not that kind of person. Okay, just come to the topic. Okay, so this will go towards the A to B, and if they basically when will be the flow basically stops? Water flow will stop at
When A and B is equal.
when A and B is equal. So you need to flow basically. Suppose that this is your current. If you need to flow the current, so basically current is nothing but flow of charge. Suppose that water is electric charge. So you need some potential. Basically, the one is at higher level and second is at lower level to flow the electrons.
Yes, sir.
Yes or no? So you will require some higher and lower value, because electrons without any higher and lower, the electrons will not flow. If you are sitting here and the person is sitting here, if you need to throw a ball towards that person, you need to apply some force because you are at same level. But one person is at high and one other is low. You will just you will not apply some force, the ball will reach to the lower person. Clear or not?
Yes, sir.
Yes, sir.
Very good. Very good. So that's why the thing basically, the potential difference is nothing but it's the difference of 2 points in a circuit. Okay, it's nothing but if I basically basically the point is here and one other point is here. So the work done to carry this charge from this point to this point. In electric potential, we have taken that from infinity, but in potential difference, we have taken 2 points, specifically 2 points. Clear? Potential difference gives you the idea how much the current will flow. So see that if the potential difference is very high, the higher amount of current will flow. If the potential difference is almost low, so negligible amount of current will flow. Clear, everybody?
Yes, sir.
Now, is
Yes,
that
sir.
clear to any doubt, anybody?
No, sir.
Very good. Let's write down the definition here. The potential difference is the potential difference between 2 points
So, potential difference is proportional to
proportional to
electricity. Electricity.
yes. That thing is explained by Ohm's law. You have already heard the Ohm's law, yes or no? How many of you heard the Ohm's law?
I have some.
I have. V is directly proportional to I.
Yes.
Have you heard this or not? Everybody?
Yes, sir.
Yes.
Samina and Kiran, why are you so silent? Everybody. When I just forgot to mention that Samina and Kiran are the 2 new students in our batch. Welcome them, okay? Who is AA? Abdullah, are you?
Yes, sir.
Okay,
Yes, sir.
okay.
Actually, by mistake, I wrote it like when I joined the class. I didn't notice that it was written Abdullah. So like I didn't see. Now I saw it. So like I changed it to A,
Oh,
like Abdullah.
okay. Electric circuit is defined as okay. So, Shweta, dear, you can unmute yourself for the while. Is defined as the amount of work done in moving a unit charge from one point to another point. Another point. Because we are moving from one point to another because we have two certain points. We know the location. But in electric potential, we basically come from infinity. Take that charge from infinity. Clear, everybody?
Yes, sir.
Very good. So basically, the equation for this is W is equals to, or V equals to W by Q. Same thing. Potential difference is also a scalar quantity because
V is equals to work done by charge, right?
work done by charge, unit positive charge. Clear, everybody?
Okay.
So potential difference is also a scalar because difference is nothing but we are subtracting a higher potential to lower potential. We are subtracting two values, nothing but that. SI unit will be same as it is. If you subtract two apples, basically you have two apples, and if you subtract one apple from it, what will be left? One apple or one mango?
Android.
What are you saying?
Android.
No, apple will be left. Okay. Everybody got it or not?
Yes, sir.
Yes, sir.
Okay. One more thing is that volt is potential difference is measured. The instrument used to measure volt or potential difference. Whenever the word we use voltage and volt, it's nothing but its potential difference because electric potential is of no use in the real life. Because we don't have like infinity. Can we take the positive charge from infinity to a certain point? But we need to basically define the thing electric potential. Then after that we can define the potential difference. That's why we have used that electric potential term, voltmeter. Next thing is voltmeter has very high resistance. I will tell you what is resistance in the coming part. Just think that it has very high resistance. Clear, everybody?
Yes, sir.
Yes, sir.
Voltmeter is connected in parallel of the circuit. That's what the value, the properties of voltmeter. Clear, everybody?
Yes, sir.
Any doubt?
Yes, sir.
Adil,
sir.
Shweta, Hiba,
No, sir.
Abdullah,
No,
Samina,
sir.
Kiran, Karishma. Okay, that's great. That's great. Let's we have only 3 minutes left or 2 minutes left. Let's do one numerical. This is the numerical of this. Okay. So, solution. The question is saying that how much work is done in moving a charge of 2 coulombs from a point 118 volt to a point 128 volt. So what first thing, let's suppose that V1, this is a V1 potential. V1 is there given as 118 volt. Clear, everybody? V2 is given at 128 volt. So basically, if the work is done, we have given 2 points. So which concept will be introduced? Potential difference or electric potential?
Potential difference.
Yes. So let's say that potential difference, that the difference between these 2 points is V. So 128 minus
So 10, 10,
118 is equals
V,
to 10
V
volt.
equals to 10.
Clear? And Q is given as
Yes.
2 coulomb, 2C. So the value is V equals to W by Q. So is 10 by 2, which is equals to 5 of what? Volt,
5.
joule? Kya?
No,
Okay, just a second.
yeah, 5 joules.
Okay, so sorry. We need to calculate the work done. Calculate the work done.
2 into 10.
Yes. W by Q.
The-
We need to calculate the work done. W is equals to V into Q. Abdullah gets very excited. Like whether it's right or wrong, it doesn't matter. Like Abdullah is very excited in all the time. Joule or volt?
Joule.
Adil said Joule. Shweta, Hiba, Abdullah, Samina, Kiran, Karishma.
There is joules probably, yeah. Work done is, I guess, measured in joules. I have like seen in the notebook.
Okay. What about others?
Volts.
Volt. Hiba said. Who said volt? I think Karishma said volt. What about Samina and Kiran, dear? Both of you answer. Hiba said something. Hiba, what you said?
Volt because no, not volt. Sorry, I saw potential difference was joules work done.
Joules. Samina and Kiran, are you there? Okay, Shweta said Joule. What about Samina, Kiran, and Karishma? Okay, Shweta said someone is saying Joule. Sir, there's some problem with my mic. Okay, Karishma, Joule.
Sir, I also said joule.
Okay. It's Joule. Very good. It's Joule. Because work done is always calculated in Joule. Clear?
Yes, sir.
So everybody tell me the topic what we have covered so far is that the like conductors and all the things. Is that clear to everybody? Does anybody has any doubt? Does anybody have doubt?
No, sir.
Very
No,
good.
sir.
Okay. Great. Okay. Shweta, Hiba, Samina, and Kiran and Karishma. You can tell me on chat if you have any doubt. Okay. No.
Sir, V is equal to V2 minus V1. Can you explain that?
Hiba, we basically we calculate, basically subtract the higher minus in lower. This is at higher potential. This is at lower potential. We're taking a difference. So difference will always be
yes, sir.
positive, na?
Yes, sir.
I've told you scalar, one more thing, scalar quantity cannot be negative.
Yes, sir.
Yeah. So scalar quantity will always be positive. Is that everybody clear?
Yes, sir.
Any doubt?
Yes, sir.
Okay. So that's all for this
No,
class,
sir.
everybody. Okay. So we have to end this class right now. So because like another class is going to start. So we have to leave this classroom. Okay, everybody. Thank you so much for joining me and take care of yourself. Okay. I'll be
Thank you,
sending,
sir.
welcome dear. I'll be sending some homework to you as well.
Is that an
Thank you,
assessment
sir.
today?
No assessment for right now.
Okay, sir.
Okay.
So there
Okay.
was like math test yesterday, right?
Yes.
So like I informed the like Learnivio people that I won't be able to attend. Like at for the timing of slot 1, I was sleeping, and for slot 2, I had to go out. So like I messaged them. They said okay. So I said them to reschedule. Like do you know when they will be?
I
At
don't
what
have any
date?
idea, dear. So okay, Abdullah, we'll be talking in the tomorrow's class because right now the start is like already